I'm Dorian. Today, I'm going to talk to you about a design pattern for integration testing. So I'm a senior developer at Hashrocket. We're a consultancy, and we do a lot of Rails. And as a consultancy, we see a lot of apps coming in different stages of their lives. Some of those apps have tests. Some of those apps, unfortunately, don't. And that ends up costing the client a lot, especially when upgrading Rails or something like that. And before we get started, just so I kind of know the crowd and know who I'm talking to, how many people here, just raise your hand if you've written an integration test or a feature test of any sort. Yes. That's awesome. So, and then have you ever done it with Capybara and RSpec? Yep. All right. It's the right crowd. So, my goal today is to give you a tool. It's more of a design pattern for creating maintainable, expressive integration tests with RSpec and Capybara. So first, we're going to talk a little bit about some types of testing. We have unit tests, and they help us drive the design of the software. We're not going to be touching that today. There's manual tests, and that's what automated integration tests are trying to solve, because those take a lot of time. So integration tests really touch every layer of your application. The database, the views, the decorators, the models, external services sometimes. So they're really complex. They're hard to write. They try to emulate user behavior. So they'll do the same thing that the user would do. They would go and open a browser and click around. And then they're really good at setting up complex scenarios. So sometimes you'll have to set up a bunch of different actors in the system in order to get the test to work for you. However, they have a bunch of different problems. One of the main problems is they're really slow to run. Unfortunately, I don't have a magic bullet today about making your test faster. But I have a magic bullet for other things. They are harder to write, and they take a lot to set up. And that makes them expensive. And as a result, we tend to only test the happy path, or mostly the happy path, right? They're also harder to read, and they tend to be repetitive, because we have to use the same selectors and the same ways to access the page and the elements on it throughout multiple feature tests. Lastly, and that's a pain point for a lot of people, they're brittle. Right, so you write it and they break. You change the tiniest thing, you replace a JavaScript framework, or you upgrade jQuery, or you do something really small. The designer changes something small, and everything just breaks. And that's hard. So the tools that we have out there today, there's a lot of other tools, but the ones that are the most popular in the Rails community are Capybara and RSpec, and then Cucumber and Capybara. Those are the two main players. And Cucumber is OK, but in my opinion, it's hard to maintain Gherkin. Like writing feature tests in this kind of weird natural language / robotic language is kind of weird. It's also really hard to maintain. So if you have multiple of those and you try to reuse them, it's really hard. And then trying to come up and write them on the fly, remembering how you wrote that natural language step is really, really hard. And your editor would probably not really help you with that. A lot of editors break. Lastly, we were promised something. We were promised that business people are going to go and write feature tests. They're going to write the given blah, 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 and blah, blah, blah. It doesn't happen. In my experience, maybe some of you have business people that do that, but in my experience, it doesn't happen. And so I don't see a reason to write natural language. It's, to me, a mental overhead. So I think that RSpec does integration testing better. And I apologize if you can't read those slides from far away there. There will be some more code-intensive ones soon. But yeah, this looks great. I think you define a feature, user signs in, and then you define the scenario, And you create a user, and then you go to the login path, and then you create a form. You go in the form, and then you fill in the username and password. You log in, and you check that you have success. Like, so far, this is as simple as it gets, right? It's pretty expressive, too. But it gets messy really fast. So one of the problems with that is that the TDD cycle, the red-green refactor that we all know, is broken. We can't get a good red because we can't write a test. We'll probably write comments of like how we want to test, but we won't write the actual test because we don't know all the selectors. We can't keep all of them in our head. So you're stuck with, what do I write next? Next, the tests are brittle. We are tightly coupled to the UI elements, to CSS selectors, to text copy. And they are very hard to read. Not the previous example, but the example I'm about to show you. They're too low level. They touch too many things that are not related to what you're actually testing. They're not declarative. So this is an example. And there's a lot going on here. There's a lot of like yellow. And yellow means usually either copy or it means like a selector in this case. So it's hard to know what's going on here. A customer tries to purchase an item, and then I try to go based on like the product title selector, which is some ID. Really weird. So the solution is page objects. It's not a new idea. It was first introduced by Martin Fowler, as far as I know, in 2004 as window driver. And later on, it was popularized by Selenium as the official documentation way of reducing test maintenance and code duplication. Unfortunately, it's not very well known still. Not a lot of people use it, not a lot of people know about it, and if they do, if you have used page objects, I do have a little cool thing that I'll show you at the end that I built. So what are page objects? So take those two screens here. Page object can be either the whole page and interacting with everything on the page, but it can also be a component. So if you have a header or a nav bar, that can be a page object. They can also be multiple pages. So if you have multiple pages that are related to the same interaction, you can assume that maybe in the future they will be refactored into a single page application that will do all of those things into one, as one page. So you can treat those as semantically as a workflow object. That's how I like to think about them. So why use them? They allow you to write expressive tests. They are more conducive to TDD, and they make tests less brittle. And lastly, you can reuse them. So you write a page object once, and you reuse it everywhere. So they don't solve all the problems, but they'll solve some of them. So how do you write them? You create a plain old Ruby object. It's just a class. And then you include Capybara DSL. This is what it looks like. So we have the module pages. I like to scope everything. Then inside we have a page object for confirmation, confirmation page. Inside of that, we're including Capybara DSL. And then to verify that we got to the page, we have a predicate method. Those are methods with a question mark at the end, return Boolean. And we use the Capybara DSL has selector to check if we have age 1 with the text that we expect. They live in spec support pages directory. In this example, checkout confirmation lives in spec support pages / checkout confirmation. And then to include them, there's already something in your spec helper, Rails helper. You just need to uncomment it. Do read the comment above when you get a chance when you do that, because it talks about performance. So one of the cool things about them is that you get free RSpec matchers. And RSpec matchers are cool. You don't have to think about them too much, but just this is what it looks like. If you define a method on your page object called onPage, then you'll get a way to query it or assert on it with the RSpec asserters. Basically, expect confirmation page to be on page. The same thing happens with has something. So has card item count will be converted to have card item count when you assert it. So today we're going to look at an example application, something that we all know, and maybe not all, but I'm sure a lot of you know, and that is Amazon. So I actually own this game. This is a card game that I really like. And it's really simple. Basically, you're supposed to not draw the exploding kitten. Everybody takes a turn and draw a card. So the first thing we're going to do is we're going to try and buy this. I'm going to write a script that's going to go to Amazon, find this page, assert that we are on the page by finding the title, assert the price is the correct price, and then click Add to Cart. Then we're going to get the confirmation page, which says Added to Cart. So we're going to verify that we're on that page by checking that that's there. And then we're going to see that the frequently bought items, kind of like the upsell stuff is there. And then we're going to click Proceed to Checkout. At that point, we'll get to the checkout page. We'll assert the address is there, and then we'll check also that the total is there. We'll select the shipping method, and we'll press place your order. So when I was writing those slides, I was on Amazon, and I was clicking around and adding stuff to my cart, and I'm like, oh no, this is not the right size. And at some point, Amazon was like, you're gonna buy that? Imagine doing that in real life, in a real store. It's gonna be awkward, right? So yeah, at the end of it, yeah, I didn't buy that thing. I bought something else. But I was already on it. We're going to assert that we got to the thank you page and we see this message. So let's go line by line and try to build it up. So we have a feature. We defined customer purchases an item. This is its own file. That's where it lives. And then the scenario is they have a saved payment information like I did. And then there's the setup part. I'm going to skip it because it's not really important for the talk. We create a page object. So I just write this out. I don't have to go and actually implement it. I just write it out as kind of like my plan of what I'm going to do. Then I'm going to tell it to visit the page, expect to be on the page, check that the price is right, and add it to the cart. Now we're transitioning to a new page object. So now we are in the cart add confirmation. So we check that we are on the page, and then we check the upsell items are equal to the upsell items that I think should be there based on my setup. Now you'll notice that I did this one a little bit differently because, and there's a reason for that, because RSpec gives you built-in diffs. So if you pass it like an array and you assert on an array, then the diff will show you why they're different and how they're different. So that's why I didn't write that as a predicate method. So it's important to know when to use predicate methods and when not. And then we click Proceed to Checkout. New page object checkout, in which I combined 2 pages, the thank you page and the checkout page. So I check that I'm on the page, select the shipping, free 2-day shipping. Thank you, Amazon. And then check the shipping address is matching the customer that I built. And then the total is the same that it was before. Click place order, and then check the confirmation message is there. Again, that's a different page, but it doesn't matter. So that's it. I just wrote it out. I didn't have to type any code other than that, and I wrote it in mostly kind of like English with underscores. So I think that's very expressive. So let's run the test. That's the red-green refactor. So we run it, and we get our first good red. Woo! So if we look back, I really wanted to show this slide, sorry. Took me hours to work on it. So let's look at this slide. It tells us that the pages product is not a thing, uninitialized constant. That's great. So yeah. And so we go ahead and implement it, right? We go to this file, we create a new file. We add model pages, class product, include Capybara DSL, initialize it. We'll just start with the first method, right? Set it is a local. You don't have to pass anything to initializers on all of them, but in this one, this is kind of like a show page. So I think for a show page, it makes everything easier to pass the actual object in. So let's run the test again. And we got the second good red, right? We can't visit page. So now we're really moving. I actually photoshopped that. So yeah, we're going to write that now. So we're going to go in and add a method, visit page. Very simple. I included Rails application routes, URL helpers. Don't worry about Capybara error intel. I'll show you about that later. Then we do the has price and so on. I don't have to go and show you everything, but I hope you get the picture. So we went from this, before page objects, which is, it's hard for me to read this. It's hard for me to look at this. I don't want to look at this. To this, which is, we're really saying what needs to happen. We're talking a very, very high level instead of like messing with UI selectors. And it's reusable, right? So if we have another process that uses the checkout, then I'm going to take that same page object and reuse it. So I introduced this concept in my team at Hashrocket, and one of the biggest feedbacks I got is that the error messages suck. Like they're really, really bad. Let me show you. So we expected to be on page, expected it to return true, but got false. Great. What do I do with this? Capybara is known for having great heuristic error messages, which tells us, something like, I expected this age 1 to be on the page, but did not find it, but I found something similar that matched partially. So I built something called Capybara error intel. And it's a simple thing that you just include right after Capybara DSL. It's about 30 lines of code, so it's really simple. Don't worry that you're adding like some heavy dependency. It's really, really simple. And this is what it looks like when you add it in. It's just one more line. And you get back all the errors that you're used to. You get the age 1. So in this case, I expected a selector, a CSS selector of age 1 with a text index. And the Capybara is telling me, like, I found age 1, but it has a text of posts. So it's different. So that's a good way to get a good read. Yeah, so it's still like, I launched it probably like 2 days ago. So any feedback, issues, PRs, GitHub stars, whatever you want. It's appreciated. So let's talk about best practices. There are no assertions in page objects. It's maybe debatable. Some people might like that. I think that assertions semantically belong in your tests. They don't belong in your page objects. That's kind of an abstraction for the page. Know when to use predicate methods. If you're going to check that something is equal to an array, like that's a great opportunity to use RSpec's built-in diffing tools. So know when to use that. For the most part, most assertions are true or false. So it makes sense to use predicate methods. Prefer to use user language, so high level. Whenever you find that you're doing something that's super specific to how this page interacts, then extract it out. Just put it in, it's kind of like how you won't put your cups and plates just like hanging around in your kitchen. You want to tuck them away in their designated cabinets. And then a page object does not have to represent one page. So in the case of like the confirmation and the checkout, it made more sense to make them into one page despite being 2 pages. Lastly, don't make a method in the page object do too much. If it does too much, it's probably not going to be reusable. So try to remember that. There are some noteworthy libraries out there. I personally don't use libraries for that. But they make it easier to, I guess, set up a page object. I think the Capybara DSL gives you most of what you need. But if you do want to check those out, they're going to be in the slides, which I posted. And in conclusion, page objects are great in my opinion. I think they're way more maintainable. They keep your code dry. They read a lot better. The tests read a lot better. And they are reusable abstractions, so you write it once and use it everywhere. You don't have to jump in right away, but if you have tests already, integration tests, just try to refactor them gradually. Try to see if it works for you or not. And give Capybara DSL a try. Just include it in and see what you get. It's everything that's available in your test normally should be available in your page object, including the page itself. Leslie, I hope you try Capybara Error Intel and tell me what you think. That's all I have for you. The slides are going to be on talks, doriankarter.com/talks. That's it.